I have built a simple linear regression model of machine learning by using teams.csv file, where we are going to predict the number of medals won by an individual country on the basis of two parameters, athletes and previous medals. Let's see. Let's run this. First of all, let me clear this. First of all, import pandas as PD, C1 as SNS, NumPy as NP. From sklearn.linear model, we import linear regression. To calculate the error, we import matrices from sklearn. Let's run this line. Okay, this is CSV file teams.csv. Here it is. We have columns events, athletes, age, height, weight, medals, and previous 3 medals. Let's run this line and create the data frame. Here it is. Now it is very essential to check the data types of each column. Here we are fine because team is object, here country object, medals int, it's all fine. Now we are going to predict the column medals. So let's check the correlation of the column with other columns too. As we know, correlation ranges from 0 to 1, where 1 presents that the relation is very high. Let's see here. We have events 0.7, it is quite high. Athletes 0.8, high enough. Previous medal 0.92, it's a high too. And previous 3 medals 0.9, even high. Here we can see medals. Medals with medals is 1. It is obvious that relation of medals with medals is 1. It means very high relation. But we are only going to use columns columns athletes and previous medals to predict medals. We can use other columns too, but for now we are just using 2 columns. Let's see how it goes. Now let's make a new data frame where we will only keep year, team, athletes, previous medals and medals as columns. df, here it is. Now check the correlation. Let's see if there is any null value. Is null.sum. In previous medals we have 130 null values. So let's see the rows. Okay, these are the rows where previous medals has null value and n null value. 130 rows. Yeah, as it shows 130. It's the number of rows. Now let's drop the 130 columns which has the value null in its previous medals. Okay, it is quite complicated. This line is quite complicated, but later I found that df.dropNA is a method from where we can easily drop all these rows. Previously I don't know about that thing, so I used this method. Let's drop this. Okay, now let's check. Okay, now it doesn't show any rows. It means all the rows with null value is cleared out. Let's sum it. Okay, previous value is 0. Previously we get 130, now it's 0. It means all values are deleted. Let's draw all linear line with x-axis as previous medal and y-axis as medal. We can see the relation between medals and previous medals. We can see it is a linear line, so there is correlation. Let's see this. Medals as y and athletes as x. df, let's check it again. Okay, train data. As we know that data shall be divided into 2 parts, for train data and test data. Usually we do it on the ratio of 80 to 20. The values where the column year is less than 2012 are going to be train data. So we have a total of 1609 rows for train data, and for test data we have 405. So the ratio is quite 80 to 20 ratio. we previously imported this linear regression model. Now we are going to use it to predict our models. Regression. Let's import this. Now regression.feed. We are going to feed into our model the trend data. We are going to feed the trend data of the columns, athletes, and previous medals to train our data medals. This is from our train data, not the test data. Let's run this. Okay, it is successful run. Now predicted medals. Now we are going to predict test data. From test data we are going to predict athletes and previous medals, and we are going to predict nothing than medals. Okay, medals are predicted now. Let's see the predicted medals. Here it is. We have a negative value 2 and decimal 2. Decimal and negative value. So we have to remove those all. Let's make a new column to our test data, where the column names will be predicted medals and the values will be predicted medals. This array. Let's run this. Okay, predicted medal. There is predicted medal in our test data. Now, as we know that the total medals can't be negative and in decimal values, so we are going to remove all those negative value with 0 and decimal by rounding it off. For less than 0 the value will be 0. Okay, here we go. For values with less than 0, for 0.96 the value will be 0. Yeah, and we are going to use the dot round to round it off. For 1.5 it will be 2. As you can see, it become 2 for value 1.5. Now we are going to test is there any error by using mean absolute error. We previously imported it from the matrices. We import mean absolute error, so we are going to use it right now. Let's see this. Okay, let's run this line. Okay, here error MAE. We get a error of 3.2. We don't know whether it is a large error or a small error, so we are going to use dot describe to see the standard deviation. We can use a dot std too, but let's see. Describe. Here we get standard deviation of 28.8 in comparison of 28.8 with 3.2. It is significantly low, so it's a good error for us now. Now we have predicted data. Yes, now let's see how it goes for the country USA. For country USA, previous medal was 317, athletes 689, and medals it won was 248, but our model predicted 285. And for year 2016, the medals won by USA was 264, but our predicted medal was 236. It's quite well for now. Now percentage of accuracy. Let's see the percentage of accuracy. How accurate was our model? Accuracy was 88.9 percentage. 88.9 percentage. Okay, now you can check all the other values. It's okay for now. We got an accuracy of 88.9. It's not too well, but okay for now. To improve the accuracy, we can use other columns. We have seen earlier that the correlation. Where is the correlation? Yeah. The correlation of athletes was 0.8. We used athletes, but with events it was 0.7. It's quite high too. We can use it to train our model. We can use this event column, athlete column, previous medal column, and previous 3 medal column to predict our data. To get medals. It's okay for now. It was this all.